Okay, good morning everyone. Today we'll be looking at Faraday's first law of electrolysis. Although Faraday discovered two laws, his full name is Michael Faraday. He worked on so many things about electricity, but today we'll be talking about electrolysis. Now, last week we mentioned that when substances break down in water, some goes to the anode, which are the anion, and while some go to the cathode, which are the cations. I know you remember all these things. Okay, so today we are looking at Faraday's first law. It states that the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity. Now, this mass of the substance means how much of that substance will be deposited. Like, for example, if I have this, and this is my electrode dipped in water, and this is my current, this voltage up here is my battery, and I'm trying to break down maybe sodium chloride. When it breaks down, it gives me Na plus and Cl minus. The Na plus, this is plus and this is minus. The Na plus will go to the minus, while the Cl minus will go to the plus. Now, amount of these things that will be deposited depends on how much electricity that is passed through. That means if you use small current, small battery, you get small mass. If you use big battery, you get big mass. So we say the mass of a substance deposited during electrolysis is directly proportional. This one directly means it's exactly proportional. Like if one is going up, the other one too will go up. Like when the quantity is high, the mass too will be what? High. Quantity of electricity means how much battery, how much current are you passing. If you use that small battery, remote battery, you get small mass. If you use car battery, very big battery, you get big mass. So let's go for the last time. Faraday's first law of electrolysis states that the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity passing through it. Mathematically, so that we can start solving some questions. Mathematically, we said mass represents M. That is how heavy that substance is. The quantity of electricity represents Q. That is the current you are passing. So we say M varies directly to Q. Varies means that as M is increasing, Q2 is increasing. As Q is small, mass 2 will be small. Then if we want to remove failure and put constant, then we say M is equal to, this is basic mathematics. M is equals to constant Q. But in electrolysis, our K has a value, and we say K is represented with Z. This Z means electrochemical equivalent. We will talk about it more as time goes on. So we'll replace K with Z. So we say M is equals to ZQ. And in basic physics or basic science, we said for you to get the quantity of electricity passing, you must be able to note the current and the time. So you multiply the current and how long it's taking for that current to pass. That will give you the quantity of electricity. So we can therefore say M is equals to ZIT. This IT is same thing as saying Q, because Q means I times what? T. Now this is our first formula. Then Mr. Faraday is saying that if you have a substance that has +1 charge, you know we have some things that are +1 and some that are +2 and some that are +3. Like for example, if I have sodium, sodium is plus. Plus means it has lost initially from basic chemistry. Then if it's going to gain 1 electron for it to go back to sodium. Now, for you to gain this 1 electron, that means it requires 1 Faraday. 1 electron means 1 Faraday. If there's 2 electrons, it will be 2 Faraday. Please follow me as we go on. Now, if I have copper 2 plus, gaining 2 electrons is going to give me Cu, because 2 plus means it will gain 2 electrons. 1 plus, 1 electron. 3 plus, 3 electrons. I know many of you ask me how do we get plus. With time, you understand. Just keep following this page. Now, Cu2 plus would gain 2 electrons for it to become 2 copper. Therefore, 2 electron has how many Faraday? 2 Faraday. Now, if I have another one, Al3 plus. 3 plus means what? It will gain what? 3 electrons. Therefore, it will become Al. So, how many Faraday has this guy? 3 electron equal how many Faraday? 3 Faraday. Now, note this, that every Faraday means 96,500. That means for sodium to be deposited, it needs 96,500 coulombs of electricity. And for copper to be deposited, it needs 2 times. So if it has 2 charge, the Faraday will be 2. If it has 3 charge, Faraday will be 3. So 1 Faraday means 90,500. It's constant, doesn't change. Just know this number. 2 Faraday is equals to 2 times 96,500, which will give us 193,000 Coulomb, and so on and so forth. If we have 3 Faraday, it will still give us 3 times 96,500. So now, therefore, to impute our Faraday, we now convert this, our initial formula here, we now convert it into mass over molar mass. Mass over molar mass equals to IT. Hope you know what we mean by IT. IT means quantity of electricity over CF, where M is the mass, big M is the molar mass, I is the current, and current is represented with ampere. So anywhere you see A, it means current. T means time, and your time must be in seconds. Then the C means charge. Charge means all these things. Plus 1 means 1. Charges, that means C will be 1. Plus 2, C will be 2. Plus 3, C will be 3. And Y my F means Faraday. And you know that our Faraday is constant, which is what? 96,500. Then if IT is not given, you can replace it, or you can replace it with N is equals to Q over CF, where N means number of moles. You know, in basic chemistry or stoichiometry, N is the same thing as saying mass over molar mass. Then Q means quantity of electricity, which you can get by multiplying I times T. So you can use either this formula or this formula to calculate Faraday's first law. Or depending on the question, if you are given Z, Z means electrochemical equivalent. If you are given Z, then you can now use this formula. Thank you very much. Next class, we'll take 1 or 2 calculations, then we'll move forward.